based on the robotic arm, the working process and its application. Let's say students explain the activity based about the robotic arm. It includes
So now we're going to see about the robotic arm. Which robotic arm is mainly used as a human arm purposes, which we can use to lift an object. We can do the repeated progressing as a continuous motion using this robotic arm. Wherever the repeating same work is going on, we can use this robotic arm to do that stuff, and this can be used as a cobot for external uses, and mainly industrials use this robotic arm for assembly and cobot purposes. And this robotic arm consists of many rotating parts and high joint mechanisms, which serves as a servo motor for turning and for lifting purposes. And we use grips for holding an object very firmly. And the main motherboard or main microcontroller we use as a ESP32 or Arduino boards, we can use as a main controller. And this robotic arm is highly used for basic part lifting and assembly purposes, like assembling a switch, assembling a motor drive. Like that, we can use this 3D printing arm. In this, while rotating or while movement, that some vibrational and errors may be occur. And this robotic arm is highly precise, but even though there will be some errors due to some technical lags and microcontroller issues and jumper pin issues, so these issues and their accuracy and precision things can be found by using finite element analysis by vibration analysis. So this will explain by team members.
So in this robotic arm, there are many systems used here: mechanical, electrical, and CAD systems used here. So let's talk. What are the systems? What are the components used here? So main components used here are sensors and actuators. So sensor which detects the environment, and actuator which performs the action. So these signals from the actuator, from the sensor to the actuator are given through microcontroller, as my friend said. So microcontroller, this is like a brain of this system. So it possesses the control where we should give the electricity and where we should not, and how much electricity should be provided and how much signal and what frequency signal should be provided, so that this motor makes the robotic arm move in the particular direction. So this can move in 9 axes, which is x, y, and z, negative and positive directions. So as a friend said, this is a simple concept which is made complex, so that many applications can be done in this. So here there are groupers, there are gear systems for which there is a grouper used here, and an LED to indicate that if there is a connection between the object and the grouper. And the next motor here is responsible for this XY motion, and this just represents the responsible for the Z and Z motion, and here is responsible for the rotation motion, which is X and Y. So here there is a base which is it is like a mechanical support for this robotic arm to progress, and for this to work standalonely, there are integrated processor and a power supply which is specialized to this robotic arm, so that it could autonomously work.
So I'm going to talk about the design process of this robotic arm. So design process is important before manufacturing, as a good design can result in a better product, often better outcome of the product. So as for this robotic arm, there are 3 designing levels to verify one by one. The first one is the base. For this robotic arm, the base is one of the most important part, which is responsible for making this motions and everything stand in one place. If there is vibration, if the base is not strong, it will move forward and backward. Sometimes it may also fall. And this base also consisted with battery and other electrical components to move the same one part. So the stage 1 part is consisted of one servo motor and two handles which supports the second stage of this robotic arm. So these servo motors have a predefined dimension, and when you design, you should leave space for that predefined dimension, and you have to design this axles. And for the second stage, there is again one more servo motor and again two axles, all having the same dimensions and same lengths. And for this last stage, which is a gripper, it has one servo motor and one gripper, which is consists of two gears, which moves for open and close. And same for this, the servo motor dimension is same, and you have to leave the gap for it. And these grippers have two gears, and the gear ratio has the gear ratio is important for the flexibility of this gripper, and it is very important to be noted. So after knowing all the components in this, you have to do a rough sketch of this robotic arm in a paper or in a e-drawing, and then you have to do 3D modeling of this model part by part, and you have to assemble it. And the electronics in this wires are they are wide, and you have to put them into correct places. If not, when it is moving, the wires may hit this parts. So you have to do support structures like this to keep the wires in one place. So this is the overall design process.
So let us see the applications of robotic arm. In material handling, robotic arm is used to pick, place and move from one location to another location, and it is also used in automobile industries for spark welding and arc welding. Also used in automobile industries, and which is used in hazardous places. So let me discuss about the advantages and disadvantages of the robotic arms. Advantages includes robotic arms can do tasks quickly and finish the work in less time than humans. So it is safe for dangerous works in risky places like welding, chemicals and factories. So by keeping robotic arm, the work will be high precision. Um, and disadvantages includes robotic arms are highly expensive for purchase and installation, and they require regular maintenance. And it also replaces the humans, and they need skilled laborers to operate and control the system.